got an open pit mine, and it's got 5 trucks, and the trucks are here. What you see here is over a 24-hour period, in other words, 2 shifts, exactly what the trucks have done in accordance to these color-coded categories. And you can see the shift starts at 8 a.m. You can see these trucks got out of the gate spot on, more or less at 8 a.m. This guy was delayed. This guy was delayed. Interestingly, these guys got out of the gate and then they go to the shovel, and you can see they spend a lot of time at the shovel, this dark color. It's because the shovel's not ready. You see subsequently when they come back to the shovel here, that's a much shorter period. So that's how much they should be spending at the shovel. So there's a few things to note here. First and foremost, the color coding here in terms of what the trucks are actually doing, the demarcation of those activities is fully automated. No human intervention at all whatsoever. That's significant because most competitor systems require some kind of intervention, which invariably means people mess it up, which means that unless Samsung has messed up their actual device, their phone, we can tell you that this is where the truck was and what it did, right? So that's the first important thing. Second is, once you get this information, the ops guys can get very excited because they can look at, the shovel wasn't ready. They can start shouting at the operator of the shovel, or they can see who started the shift late. We can see the evening shift ended early. They're supposed to end at 7. They ended half an hour earlier, but it started at 8 p.m. on time. We can see that the morning shift is terrible. There are cycle delays. What you want is a lot of this golden stuff, which means they're at the shovel, right? So you can see in the evening shift that they get to the shovel quite often, but then you get these long periods of waiting at the tip, okay? So the question is, we can see all these problems, the ops guys love it, but of all these issues that we're looking at, which are significant and which are not, okay? And that's where we come to the party with our analytics. So what we do, we take each of these activities and we bundle them into appropriate categories, okay? Such as dumping time, cycle delays, average speed full, average distance full, etc. And we mathematically, so these values that we see here correspond directly to these activities. And we mathematically derive how those values affect what matters to management, the tonnage hauled. So what we see here, let's start with the target. The mine has agreed what the targets ought to be. And they agree that 2.3 minutes dumping time is the normal dumping time. They don't have to try very hard. They don't have to improve performance. If they're operating normally, that's a dumping time. Likewise for the speeds and so on and so forth. So if you take those targets, it says in the shift, they should have done 23,000 tons. What happened in reality? They did 12,000. So the shift was 50% effective in essence, right? Why? Obviously, because they under-delivered or underperformed on one or more of these operational drivers. Question is which ones. You can look at in the tree and how much impact did those have. So whilst you can look at in the tree, we actually provide this graph to make it more intuitive and more explicit. So what we saw is we should have got 23,000 tons. Okay, so that's our starting point, our target. What this calculation tells us is, in fact, we could have done more. Why? Because our equipment count was higher than planned. We had one more truck, more in actuality than planned. So we could have got 4,000 tons more, and so on and so forth. So in essence, that target 23 was actually a little bit conservative. Okay, so why did we end up losing tons? And we can see it's actually computing how each of those operational drivers contributed to tonnage loss, and it boils down to 3: loading time, dumping time, and maintenance delays. Shift change time wasn't really an issue, even though we can sit and argue about it because they started the shift early or late, etc. It's these 3 issues. So maintenance delays, let's ignore those. Let's focus on dumping time. So we click on dumping time. That's time at the tip, okay? And we can see major delays at around 12 p.m., major delays in the evening shift. Why? The crusher's down, typically, right? So let's look at it. So we click on this here, and now it's going to pull data associated with that time point into the chart that we have below, okay? We can see the tip is actually right there, okay? And we're going to see the truck. You see the truck? It's waiting right at the tip, okay? It's this one here. And we're going to see the others come along, and they'll be waiting there. We can see there it is. It comes in and it's waiting. There's nothing to do. So here's what's important here. What we're doing is we drilling down to the detailed specifics of what the actual operators are doing to the physicality, okay? And we can actually have the discussion with operators. But we're doing so in a meaningful way. We're doing so by focusing on what's important, the tonnages, why we lost the tonnages, and isolating it to categories that contributed to tonnage losses, distilling those categories to specific events, and on those specific events, actually then going into the physical detail and diagnosing that further, right? And so in one view, we can relate what matters to executive management all the way down to the physicality of the operational events and activities, but in a way that drives that diagnostic from a materiality perspective.